Hello, my name is Sanuk, and if you've watched the previous video, you'd know that I'm making a programming language called LCP. It's a very simple stack-based programming language that has, I would like to say, most of the features of a modern programming language. Most recently, well, it's been a while, but most recently I have implemented Structs. Very, very cool. It's it's basically just a non-primitive type that you can define members of that can be assigned to either primitive or non-primitive types. So for structs, all structs, when defining a struct, you start off with the struct keyword, then you define the name of the struct. For example, here we're going to make a string. The end of a struct always has the end keyword, just like any other chunk of source code, like a function. Inside the function, inside this box or this chunk, we define the types of the value and the name of that. So, like, for example, a string needs the size of the string, which is going to be in integers. So, like, let's say that the string is 10 characters long, then that would be the I64 size, right? And then we need an array or a pointer to an IA, and that's going to be data. And that's our struct. That's our struct defined. It has two members, size and data, and that just wraps them all up. To define a struct, all we have to do is type the name of the struct and the name of our variable. So I'm going to call mine name because we're going to store a name into it. To store values, when you first initialize a variable, it's all going to be just null. It's going to be no data stored. Whatever was stored there before is going to be there. So what we can do is when we type this in quotation marks, what that does is it pushes the size and then the pointer onto the stack. So then we can go at let me just visualize that real quick. So if we have an I64 and a pointer to an I8 on the stack, that means the I8 is on the top of the stack. So we're gonna go at name.data. And what this @ symbol does is it writes it to the member that is specified after. So we're going to write it at name.data, and that consumes this IA and saves it into the name variable. And then we can do the same for at name.size. And boom, we just initialized our string variable. And if we compile it, there's no errors because our type checker works. Now what we can do is we can push those values onto the stack by using the and symbol. So it'd be at name. For example, if we want to know the size, we just push at name.size. And then if I print that out, compile it and run it, we get 3 because that's how long the word Joe is, 3. So next, something you might want to do with the string function maybe is you want to print it. So when doing that, you can't just provide a string as an argument. You always have to provide pointers to the struct, because that's how you pass the memory around. So let's do pointer to string. So we want to print that, right? And now let's go here and just say name, because that's how you push the whole pointer to the struct onto the stack, and then print. Boom. Now, to print it, what we're gonna do is we're gonna go, first of all, what we're gonna do is we're gonna save this into a new variable as our first example of how to write a function. We're gonna call it string or pstring, print string, right? And then we're gonna go at pstring. What we're doing here is we're saving this entire string struct, and we're gonna copy all the contents in that pointer into this new variable that we just created. Then what I'm going to do is I'm going to push the size, then I'm going to push the data, then I'm going to go that. Boom. And if I compile that, yep, it prints out 3 in Joe because 3 is on this one, so I'm going to comment that out. But copying all this data is not fun, and it's just a waste of data. So, like, what is another way we could do this? So in this scenario, what we can do is, instead of doing that, what we can do to make it a bit less taxing is we can write this to a pointer to a string, right? Then when we write the string on the stack, it's not copying the values, it's just writing the pointer directly into the variable. And then instead of doing this, what we can do is something like this. So I'm gonna push the pointer onto the stack by going at pstring, but since now we just have a pointer to the string onto the stack, so we have a pointer to string, what we're gonna do is I'm gonna use an indirect calling. So instead of like accessing the name directly, the compiler knows that the type on the stack is a string, so we can go at string dot size or and string dot size, whatever that symbol would be called, and that'll just get that value directly. Then we can do the same for data. Then boom, there, that's a bit less data pushed around, and obviously in this scenario 8 bytes versus 16 bytes is not that much, but at least I think. I'm not an expert on this, but yeah, that's one way you could do it. And then another way, if you really wanted to like make the function unreadable but less memory copying, is something along the lines of, so you duplicate the top value, go at string.size, right? So we have an I64 on the stack, then we go over, no, we swap at string.data, then, so we're just pushing the size, data on the stack, and printing it out, and then we get Joe again. So that's how that function would be written. That's kind of the entirety of structs and variables. Another thing we have in our programming language is more variables, but for primitive types. Let me create a new function for this. Fun, for example, maybe we have a count, right? And let's call it ink, actually. So we get a pointer to an I64. So here, let's create a new I64 variable called count, and let's initialize that variable to 0. So boom. That's how you would do it. For primitive variables and pointers, you can just do the name directly, just like when writing a pointer to a struct into a variable that's the same type. A variable into the variable that's the same type. So we initialize that, and let's say, let's print count out. So we go at count dump. Yep, that'll print 0. So then we'll call, we'll push count onto the stack, increment it, and then print count out again. And we should get 2 different numbers, but then we gotta write the function first. So for the ink function, what we're gonna do is we're gonna let's see, how are we going to do this? We have a pointer to an I64 on the stack. I did not script any of this video at all. We have the pointer on the stack. We duplicate it. Dupe it. Then we read, then we read the I64 value. That means we have just an I64 on the stack. 1 plus, so we increment that value. And then we go at I64. I don't remember the ordering for that. And I think that should work. Maybe there's a expected a pointer to I64, got an I64. That means this needs to be swapped, I think. Yep, and if we run it, yep, 0 and then 1. Let's quickly put a new line here, so those are on separate lines. Fuck. There. The syntax highlighting is kind of fucked right now because I never bothered writing one for NeoVim. But that's what it should look like. It kind of improves the language, I guess. It's a cool feature. You can use it. It's not like completely fleshed out, but it's there. It works. There's probably a lot of bugs, but like I have not encountered one yet. That isn't like me just being dumb while programming and like forgetting to add something along that line. So yeah.